Hey pre-calc students, welcome to lesson 2.4. Today we're going to talk about how to write the equations of polynomials in standard form of least degree when given factors or zeros. So quick vocab review. A factor, for example, and this is just an example, a factor can appear as 3x plus 5. Now remember, factors are things that multiply together to give you a specific product. So when you factor a polynomial, you're breaking it down into factors, so things that multiply together to give you that polynomial. Zeros, however, you can obtain by setting the factors equal to 0. So if I were to take the 3x plus 5, that was my previous factor, and set it equal to 0, subtract the 5, divide by 3, I would get an answer of x equals negative 5/3. So notice that factors are not set equal to 0. Only zeros and solutions are. Now, in this lesson, we're going to ask you to write a polynomial equation of least degree in standard form when given its factors or its zeros. So how do we start? Well, remember that factors are things that are multiplied together to give a specific product. So if they've given you the factors, all you have to do is start by naming the polynomial. So give it a name, f of x, g of x, you choose. Since they want an equation, you need to make sure that you put the equal sign in your answer. So f of x equals. Then you're going to look at the factors. They are both binomials, so since we need to write out the product, we need to put those binomials in parentheses. And we need to write our answers in standard form, so that means we can't have it written as the product of factors. We actually have to multiply it out. So we need to distribute. Remember, x times x is x squared, so 4x times 3x is 12x squared. Some teachers call this FOIL, so that's essentially what we're doing. We're distributing or foiling. And then all you have to do is just check to see if there are any like terms and combine them. So here we've got negative 8x plus 15x. That's 7x. And you're done. That is a polynomial equation that corresponds with the factors of 4x plus 5 and 3x minus 2. All right, notice that the next example gives us 3 factors, but just for a second, look at their exponents. So we have an x squared, then 12x to the first power, and then x to the first power plus 1. So in total, we have x squared, x, and x. That's going to give us x to the fourth power. So you can look at the factors and the exponents of the variables, add them all up, and that'll tell you what your final answer should have as its highest degree. All right, let's get started. Name the function. F of x, g of x, doesn't matter. You can switch it up in every problem, or you can keep it the same as f of x each time. If any of my factors are monomials, meaning they don't have any addition or subtraction, I like to put them out in front, and I don't put them in parentheses, but you can if you want to. If the factors are binomials or trinomials or any other polynomial where it's got addition or subtraction, I keep them together with parentheses. When you are multiplying 3 factors, you can multiply any 2 first and then distribute that answer with your third factor. I tend to go from left to right. So I'm going to go ahead and multiply the first 2 terms. And then whatever I get as my answer, I'm going to multiply it with the x plus 1. However, you should notice that x squared plus 12x is 12x cubed, and x squared plus or times 5 is 5x squared. That is a binomial, so when I multiply it with the x plus 1, I need to remember that I need to distribute both of those terms, so I highly recommend that when you're multiplying more than 2 factors, like in this case we had 3 factors, You can multiply the first two, keep them grouped together before you distribute and multiply with the third factor. That's just a personal recommendation that I'm going to make because a lot of students make mistakes when they do not group these. So then I keep going, 12x to the fourth. Remember, you add the exponents of variables when you're multiplying them. 12x cubed times 1 stays the same. 5x squared times x is 5x cubed. Remember, x squared times x is going to be x cubed, and then plus 5x squared. Don't forget that in your final answer, you need to have the name of the function, the equal sign, and then you have to combine like terms when possible. So if you have like terms, you need to add or subtract them. Just pay attention to the signs before you give me your final answer. So when you are given the factors of a polynomial and you're asked to write an equation, all you have to do is multiply them. Multiply them all out. But what's coming up takes a little bit more work than just multiplying the factors, okay? So to kind of prepare us for what's coming up, I want to go over some basic solving rules. When you have a linear factor, where it's just the variable x plus or minus a number, and you set it equal to 0, solving it is really easy peasy, because all you do is cancel the addition or subtraction to obtain your solution. Okay, you're probably thinking, okay, why are we doing something so simple? You'll see in a little bit. If you have a linear factor that's set equal to 0, but it's got a multiplier in front, a coefficient that is not 1, then it takes a little bit more work, but nothing too crazy. All you have to do is divide that coefficient out. Now, if something is given to you in vertex form, so remember, vertex form is a quantity squared and then plus or minus a number. You can read it's called vertex form because you can read directly from the equation what the vertex of a parabola is. So if I wanted to, and I was asked to find the vertex, it would be -3, -2. So it's a shift left 3, down 2. That's not what they're asking me for. They're asking me to solve. So when you're solving something in vertex form, you're using what I like to call SADMEP, which is the backwards order of operations. So I cancel any addition or subtraction that's outside of the parentheses. Remember, P in SADMEP stands for parentheses. I do that last. So this x plus 3 I'm going to do at the end. There's nothing being multiplied with this quantity, so I skip over, so I canceled addition and subtraction. There's no multiplication or division. There is an exponent, so I'm going to square root both sides. Remember, when you are solving and you square root both sides, you end up with 2 solutions if you square rooted a real number, so plus or minus √2. And then last but not least, cancel anything in the parentheses. So after you do the exponent, subtract the 3. The 3 is not a root, it's not a radical, so you need to keep it separate from the plus or minus √2. The 2 solutions are -3 plus √2 and -3 minus √2. Assume that we want exact answers unless I tell you to approximate your answer. That's the only time you're going to give me decimal answers. Go ahead and pause the video and solve letter D. Push play when you're ready. No cheating. Pause the video. Solve letter D. Push play when you're ready. Okay, I hope you didn't cheat. So your 2 solutions are going to be 1 plus √5 and 1 minus √5. Now, why did we go over that? It might seem so simple to you. Well, The reason you have to remember how to solve is because now we're going to go backwards. I'm going to ask you to write the equation of the polynomial when given at 0. So what I'm going to be giving you is something that looks like the solutions that we got for C, D, B, and A. And you have to figure out what it looked like when it was set equal to 0, so before it was solved, because those are factors. Remember, a factor is different than a 0, so think back to the very beginning of the lesson. A factor is different than a 0 because a 0 sets a factor equal to 0. That's why it's called a 0. So in these examples, you have to ask yourself, what did these zeros look like as factors? All right, if your solution or your 0 is x equals 6, okay, and this is all like side work, things that you can think about in your head or you can actually write out. If the solution was x equals negative 6, what did it look like when the x was on the left side and so was the 6? So what did it look like as a factor before it was set equal to 0 and solved? Well, it was x plus 6 because then you would subtract 6 and that's how you get negative 6. So what you need to do first in all of these problems is you need to figure out what these solutions used to look like as factors. So negative 6 used to be x plus 6, which makes sense because look at letter A. When we had x plus 7, a linear factor, the answer was just the opposite, x equals negative 7. Now here's a little bit of a tricky one. What did x equals 0 look like before they solved for x and set it equal to 0? Well, it's not like you can say it was x minus 0 before. You can't have a plus or a minus 0. Do you see that? So we can't say it was x plus 0 or x minus 0. It's really just x. The factor was x. X equals 0. Now, some of you are going to understand this next explanation, so I'm going to go into a little bit more detail. X equals 0, all right? So if the original factor was just x and I set it equal to 0, I'd get x equals 0. But what if the original factor, so this is just something, food for thought. What if the original factor was x squared? If I set that equal to 0, won't the answer also be 0 if I square root both sides? Yeah. But wait. What if the original factor was x cubed? Can't I just cube root both sides and get 0, right? The cube root of 0 is still 0. Yeah. And honestly, I can keep going. I can say, what if x to the 20th? And then like 20th root both sides. Won't that work? Yes, but that's why the directions say of least degree, of the smallest degree. So are there other ways for me to get a solution of 0, a 0? Yeah, I can have x squared equal to 0, x cubed. So all these other factors could work. But I want the one with the smallest degree. So I'm going to use just x, because if I set x equal to 0, I get x equals 0. Now, think back to letter B, where our answer was a fraction, x equals 2/3. So I want you to kind of notice a pattern. The leading coefficient ends up in the denominator, and the number that was, give me 1 second, the blue and the green are messing up. Okay, so the number that was added or subtracted changes signs and ends up in the numerator of your answer, okay? So essentially what you're trying to do is you're trying to figure out what did the original factor look like before they set it equal and solved and got 1/2. Well, remember, the denominator came from being the coefficient, and then the numerator is just the opposite of what it appeared like before it was solved for x. Some of you are going to take 1 second to know what it used to be. how they got an answer of 1/2. Some of you will take a minute or two, and that's fine. But no matter what combination you pick, right? Even if you're just guessing and checking, was it 2x plus 1? Was it 2x minus 1? Was it 1x minus 2, etc., right? You need to take a minute. So no matter if it takes you 1 second to think of the factor or 1 minute, you need to solve your factor and make sure that it gives you the 1/2 that we wanted. Okay? Just like I took a minute to check and make sure that x plus 6 really did equal -6 in the end when you solved it. Once you figure out what the factor is, put it back into your original product. Remember, we're trying to multiply all this out. Now, my personal preference is to put any monomials out in front. So I'm going to go ahead and just rearrange the x plus 6 and x. That is personal preference. Remember, when you're multiplying 3 factors, order doesn't matter. You can multiply the first 2, then that answer multiply with the third factor, or do the second 2 factors, multiply them out, and then the first one. I'm still choosing to multiply the first factors. I just put the monomial out in front so that the distribution is a little bit more obvious. You didn't have to do that if you had noticed that you just needed to distribute the x to x plus 6. Now, remember what I told you, you have to keep that product in parentheses because we still need to multiply that out with our third factor. So remember to group your new binomial that was created by distributing the first 2 factors, x with x plus 6. All right, from here we just distribute. You can call this FOIL. FOIL is an appropriate term when you're distributing 2 binomials together, or when you're multiplying 2 binomials. Okay, being careful with your exponents, distribute. And combine like terms when possible. Always, always, when you're asked for an equation, don't forget to name the polynomial and then put the equal sign. So as you can tell, this one took more time, definitely more time than the first 2 examples when they already gave us the factors. So again, you're probably going to have to spend a little bit more time practicing these types of problems because there's so much that's involved before you even start multiplying. Now, if you think back to examples or to C and D, right, that were written in vertex form, all of those answers gave us a number plus or minus a radical. So -3 plus or minus root 2 and 1 plus or minus root 5. Now, what kind of pattern can we notice from there? Well, the number that ends up in the root, give me just a second, my computer's a little delayed. Okay, the number that ends up in the root is the number that was added or subtracted outside of the parentheses. And it's opposite signs, right? So if it's a +2 in the root, it was a -2 in the original problem. And then the number that's in front of the radical was the number that was in the parentheses. But again, the sign is the opposite of what it was in the original. So if I use that pattern of saying, okay, well, the number with the variable x, so remember, we're trying to figure out what this used to look like when it was in vertex form, in factored form. So we're trying to figure out what the factors were, what was being multiplied together to get 3 plus or minus root 6. So the number in the parentheses is the number that ends up outside and in front of the plus or minus, and it's the opposite sign. The number in the root is the number that was added or subtracted, and it's also the opposite of how it appears on your answer. Now, if that sounded a little complicated to you, just remember that you need to kind of take your time. Some of you are guessers and checkers, so you're going to be like, okay, was it x minus 3 squared plus 6? Was it x minus 3 squared minus 6? Is the 6 in the parentheses and the 3 on the outside? Etc. So you can see that there's like a lot. I mean, I can go on forever. There's like so many different combinations, trying the 3's as negatives, the 6 as negatives, positives. So if you're a guesser and checker, you're going to have to literally try each one of these combinations until you find the one that when you solve it gives you 3 plus or minus root 6. But as mathematicians, I recommend you try to follow patterns. So the pattern is that the number in the root is the number that was outside the parentheses on the right. And the number in front of the plus or minus is the number that was inside the parentheses. What if you're going to guess and check, okay? Make sure you take a minute. So let's say pretend that I didn't remember the pattern and I just guessed that this was the factor. I would recommend that you take a minute and solve this. Square root both sides. And then check to see, does it give you negative 3 plus or minus root 6? If it does, then you can go ahead and start your distribution and your multiplication. So 3 plus or minus root 6 comes from the vertex form of x plus 3 quantity squared minus 6. Remember that an exponent of 2 next to a binomial means that there are two binomials that look exactly the same that are being multiplied. Don't forget the minus 6. Then I'm going to distribute or FOIL my two binomials. But again, don't lose, and this happens all the time, guys. Oh, and I just realized, my loves, look at, I put x plus 3 quantity squared minus 6, and I got negative 3 root 6 plus or minus. That's not what the original one is. Oh my gosh. Super salad. Super sad. I would have needed this to be x minus 3, and I'm pretty sure when I said it out loud, I said the right thing, but when I wrote it, I put something else. So I can already tell something is off, and I'm glad I went back to see it. Maybe some of you caught it. Good job. Now, remember, I did say this previously, that the number that's in front of the plus or minus changes sign, so it had to appear as an x minus 3, and that's how it ends up as a positive 3. Look, I even drew the smiley face and the check mark, but they wasn't the same as what was given to me. Now I'm good. Now I have 3 plus or minus root 6. Oopsies! Hopefully you caught it. All right, so it was supposed to be x minus 3 quantity squared. My bad. But again, that's why I said take a minute to check. I knew something was wrong, and I'm glad I went back to check it. I didn't want negative 3 plus or minus root 6. I wanted positive 3 plus or minus root 6. All right, as I continue distributing, and not forgetting that minus 6, because it happens all the time, guys. People get so involved with the distribution and the foiling that they forget about the poor minus 6 at the end. All right, so your last step is just to combine like terms, and your final answer should be x squared minus 6x plus 3. If you ever have, let's say, I don't know, 5 to 10 minutes left over. When you're taking a quiz, you have 5 to 10 minutes left over, and you want to know if you did this right. Well, this trinomial is not factorable, so you can use the quadratic formula and see if you get the zeros of 3 plus or minus root 6. So when you're done writing out your polynomial, you can solve it and then check to see if it gives you the answer of 3 plus or minus root 6. Okay, let's be a little bit more careful, right? I'm going to be a little bit more careful when I do example 5. So I'm going to try to use the pattern. So the number in front of the plus or minus, we need to change the sign, and that's the one that goes in the parentheses. The number inside the root also changes signs, and that one goes outside the parentheses. Now I'm going to be really careful here and double check to really make sure that I get an answer of -1 plus or minus root 3. So I'm going to add 3 to both sides. Square root both sides. And lo and behold, if I subtract 1, so this time I'm not going to put a smiley face unless it actually is the original answer. Okay, now I can put a smiley face. I did it right. Okay. Because x plus 1 quantity squared minus 3 is the original factored form, I'm going to go ahead and put that as my factors. X plus 1 quantity squared minus 3. Don't forget the minus 3. Write out x plus 1 twice, because anytime you have a binomial with an exponent of 2, it means that there are 2 of the same ones. Distribute. Now, you don't have to draw all the 4 arrows at the same time. You can draw one arrow, write the product. Draw another arrow, write the product. I actually encourage it because it makes you stay more organized, and it keeps kind of like, yeah, it just keeps you more organized. You do one multiplication, write the answer. Do another multiplication, write the answer. Again, if you have 5 or more minutes left at the end of a test or a quiz, what you can do is you can solve this with the quadratic formula and see if you get -1 plus or minus root 3. Now, why the quadratic formula? Because this can't be factored. This trinomial cannot be factored. So overall, in this lesson, we learned to write the equations of polynomials when given either zeros or factors. You're going to need to spend a little more time reviewing and studying how to do it when given the zeros, because that definitely takes a little bit more thinking, and you have to be really careful with that first step, all that side work, before you start multiplying anything out. As you guys saw when I was doing example 4, I messed up. So you want to make sure that you find your mistakes before you go through all the process of the multiplication. Otherwise, you got to start over. As always, if you have any questions, feel free to send me a message on Remind. I'll be happy to help you. Have a good day, guys. Adios.